Recording in
I got
progress.
Okay.
90.
Yeah,
I
that's
don't know if
correct.
that's right.
That's right. How you get 90? Because what we are saying is that the motor is traveling at 10 meter per second can bring his car to rest. Okay. So they're saying it will bring car to the rest. And since they're saying that so it will bring to the rest, it means the final velocity will be zero, right? So you will take this zero. It will become zero. And now you will have this equation 2as equals minus u square. Okay, this is your final equation. Now you need to
Yeah.
know the s. When you need to know s, so this equation will become like this minus u square over 2a. Clear?
I did it like
Mm-hmm.
different though.
But this is the correct way. Okay, how do you solve it?
Are you still on the 12th question?
Yeah, I'm just telling you.
Okay.
You are saying I don't know how is it correct or not. Your answer is correct, but I am telling you the solution. How you solved it?
Well, first I use the same formula.
Mm-hmm. Then.
The v square minus u square equals 2s.
Mm-hmm.
But I used for the first situation, I made v square the subject. It became
Okay.
v square equals u square plus 2as.
Mm-hmm.
And since it stops at rest,
Hmm.
v square equals 0. So
Yes.
0 equals u minus u square. No, 0 equals u square plus 2as.
0 equals u square plus 2as.
Yes.
Like you have taken it 2as plus u square equals 0. This is what you are saying.
Yeah. I made v square the subject for the first situation.
Okay, this is same. I have written it like this. I have taken this minus, this is on this side. Because when you take it on this side, it will be minus u square, isn't it? Because at least you have to take one
Yeah.
thing on the right hand side. You can't use this equation
But
directly. Mm-hmm.
then I made the acceleration the
Hmm.
subject. So it
Okay.
became a equals minus u square over ts.
Minus u square over 2s. Okay,
Yes.
why did you make the acceleration subject?
Because in the second part they said same braking force. So I thought that
Same
meant
working force,
same
but they are
acceleration.
asking for the distance. In what distance could he bring? In what distance could he bring the
If I
car to
knew
rest?
the
Uh-huh.
if I knew the acceleration, then I could use it in the for the second situation as well.
Okay, that's also right. If your answer is correct, you can use an equation. But initially, you must know that this you will use equation in this way. And they are saying that under a constant braking force, you see they are saying the constant braking force. When you will apply force, what will happen when you apply brakes? There will be deceleration. Okay, but they're saying constant braking force. Constant braking force means acceleration will deceleration actually. Deceleration will remain constant. So this negative part will remain constant, and so you can simply say that s is directly proportional to u square because your acceleration is constant. Are you getting my point? They are saying you have applied constant braking force. Like a car is
Yeah.
moving and they have applied constant braking force, so the deceleration will remain constant. So you just left with the s and u square factor. And if you just take the magnitude, you can write s directly proportional to u square. This was the formula I was initially using. S is directly proportional to u square. Are you clear till this? What I have done?
Yeah.
Okay. Afterwards, now you need to calculate the new distance. In what distance could he bring the car to rest? Now you need to know the new distance. So initially, u1 is what is u1? That is 10 meter per second, I think. Yeah, that is 10 meter per second. Okay, it is 10 meter per second. And S1 is what is your S1 in this question? Traveling at 10 meter per second, and S1 is 10 meter, right? This is U1 This is S1 and this is U2. Clear? Are you clear with this?
Yeah.
Okay. Your S1 is 10 meter. And they have also given you the S2. What is S2? Not S2, but they have given us the U2. That is 30 meter
30.
per second. U2 is 30 meter per second. Now you need to know S2. So can you find by this equation? Like what we can do is, S is directly proportional to U square. So when you need to calculate the uh, S2, what you will do? Hmm? How can
Um,
you remold this equation?
Fine.
Hmm. You can use this, and this can
Mm,
be this. You can change it into. You need to find S2, so it will be S1 into U2, because if you see S2 into U2 square, because a U square, then S1 multiply U1 square. Are you clear with this? What I have done?
yeah.
Okay. This was the equation that S is directly proportional to U square. So when you need to know S, when you have S1, you will use U1 square, and when you have S2, you will use U2 square. So from here, you can take this in the denominator, right? Your equation will become S2
Yeah.
equals S1 multiply U1 square divided by U2 square. Clear?
Yeah. Can I show you what I did?
Yeah, you can show me.
It's kind of messy, but I'll still send it.
Okay, good.
I did it like in 2 steps. Maybe it's longer.
Yeah, it's longer because I am just telling you the detail, because sometimes they will ask you in some other scenario as well. The braking force. This is an important concept. They ask for the same braking force, uniform force. You have applied the braking force is same. In that case, you can use it. Okay.
Recording in progress.
Okay. Then you have an object is dropped from a greater height and fall through the air of a uniform density. The acceleration of free fall is d, which graph could show the variation with time. Now they are saying what they are asking for.
They're asking for
Hmm.
the
The variation
graph,
of time with the acceleration. They are acceleration time graph when
the gradient
when the object is falling. There is a free fall motion.
falls in there. So,
Hmm.
so the gradient in this is velocity.
Gradient of acceleration time graph. Yes, it is velocity.
And they're asking for the variation time. What does that mean?
Hmm. They are saying an object is dropped from a great height and fall through air
Yeah.
of uniform density. It was at a greater height and it started falling. So it means acceleration will decrease. Why? Because they're saying and fall through air of uniform density. The acceleration of free fall is g. Which graph could show the variation with time t of the acceleration of objective?
But if it
Hmm.
falls from a great height, then shouldn't the acceleration increase at first?
Sorry, what you are saying?
If the object is dropped from a great height, shouldn't it have a bigger acceleration at the
No,
start?
because
So
there is
shouldn't the
air
acceleration
resistance. They are saying through air of uniform density. They are not saying that negligible air resistance. It is not mentioned in the question. Did they mention that there is negligible air resistance? If they will mention that there is negligible air resistance, then you can say that acceleration will increase. I
but
have. Mhm.
but even in that, The acceleration increases until it's like balanced by the air resistance.
It will decrease. It will be maximum in the start, and then it will start decreasing.
Yeah.
So because and that is dropped from a greater height. It means it is at a greater height, and so it will start decreasing. You know this one, this question, the projectile question. If you see over here, what we were saying, the vertical component is zero, right? And then when
Yeah.
if you see at this stage, the acceleration was negative. If you remember, I told you at this stage the acceleration will be minus 9.8 meter per second square when it will start
Yeah.
falling. So the acceleration will decrease. It is negative when there is air resistance available and there is air resistance present.
Mm.
Now, but which graph will be there? Which one is the
It
correct
will
option?
be.
It would not be B.
I said it would be.
No.
I said it would be something. I can't say what it was yet.
Okay, I am saying I think the option B.
Uh, no,
It will see.
it's
It can't be C, right? Because it is. We can see that this can't be C. It can't be D because
is
in
it?
D it
It's
is
A.
increasing. Hmm.
It's A because
Yes. Yes. Why?
decreases.
Hmm.
It
Because
decreases uniform.
it is decreasing with time.
Yeah.
So this A option is correct. Are you clear with this?
Yeah.
Okay. Question number 14. A car at rest in a traffic queue moves forward in a straight line and then comes to rest again. The graph shows the variation with time of its displacement. This is displacement time graph. What is its speed while it is moving? What can be its speed? Now they are asking for the speed. How you will know the speed of this? By the gradient or by
By the
the area?
gradient.
By the gradient.
By the gradient.
So what will be the answer for
You're
this?
asking for when it's moving.
Hmm.
It's you have to do 70 minus 30 over. Okay, I'll do it. Okay.
Yes, solve it.
Mm, can you zoom in a little?
Okay.
The graph. That's 100 and that's 50, right?
That's where over here at this point.
The
Okay,
other
this is
one.
100 and this is 30.
That's 50, right?
Which one you are saying? The answer?
Okay. No, I was just saying on the graph, the point down on the x one.
This one?
No, it's fine. I got it. Can you zoom out? I got 0.8, so I think it's B
Yeah, that's correct. How is it 0.8?
because you find the gradient.
Hmm. You want the gradient of you have what you have? You basically have
7.
How you solve it? You have this area as well, and then you have the gradient
Yeah.
70 and the 30. 70 minus 30 will be 40, 40 meters, and yeah, this one will be 70 minus 40. It will be 30. Sorry, 70 minus 30. You will get 40 meter, and then this is delta S. And what is time? This is 60 and 100. Not 60. This is 50. So you will get 50, right? Is this correct according to your answer?
Yeah,
And now you
70
can
minus 30
delta S over
over,
delta T.
yeah,
That will be 40 over 50, right? And you will get, what do you get from this? 40 divided by 50? I guess it would be 0.8.
0.8.
Okay. Now, next question. Which pair contain one vector and one scalar quantity? These questions are easy, right?
Yeah. Which pair contains vector and one scalar?
Mhm.
It's
If you see
it's
this
D.
A, this is a vector quantity, this is a vector quantity. Force, force is what?
Yeah,
Force is vector. Sorry, what you are saying?
vector. I said it's D. D.
In D, you have power and speed. Most of the time, they say speed is velocity. Okay, we can check this. This is scalar.
No, but speed is scalar.
No, I'm saying when they write speed, it okay, they have mentioned this over here. Momentum is vector, velocity is vector. But kinetic energy is not vector quantity. Is kinetic energy vector quantity?
Kinetic energy is, yeah, it's a vector.
Hmm?
Yeah, it's a vector quantity.
No, it's not a vector quantity. It's a scalar quantity.
Kinetic energy is scalar.
Yes.
But it can't be B if it's D.
Yeah, so that's why I'm saying we need to choose one option from this.
I think it's D.
Hmm. Speed in terms of velocity, we check that it can be, we can check it as vector in terms of velocity, right? But kinetic energy, you don't have any alternative for kinetic energy. That will always be scalar, isn't it? I'm not saying that speed is a vector quantity. I'm just saying if we go with the formula of displacement time graph, then we can say that speed can be velocity when you have direction, right? When you have displacement. So in this case, B can be the option. We can check the answer as well. I hope so. It will be. What question was that? That is 15th, and that's B. Hmm. That is why if you get any question like this, choose that option in which you just have the scalar quantity because kinetic energy don't have any alternative to which you can say that is a vector quantity. Okay. A car is traveling with a uniform acceleration along a straight road. The road has marker post every 100 meter. When the car passes one post, it has a speed of 10 meter per second, and when it passes for the next one, its speed is 20 meter per second. What is the car's acceleration? Hmm. Which formula can we use over here? You have two different values. Okay. You have this V and this is U, right? And you have the distance S. So basically, we can use third equation, right?
Yeah.
2AS equals V square minus U square. And you need to know the acceleration. You have, if you need to know the acceleration, you can use A equals V square minus U square over 2S. Clear? So basically,
Yeah.
V square is 20 minus U square is 10 square over this is 2 into 100. Okay, solve it and tell me what is the answer. It will be, I think, 20 into this will be 400. This will be 100. This will be 200. And you will get 300 over 200. It will be 1.5, I think so. Yeah. What you get?
Um. Okay.
You are not solving it.
Hang on. It's stuck on my calculator.
Okay.
It's 1.5.
It's, yeah, it's 1.5.
1.5.
My answer is also correct. 1.5. Try to
Yeah.
solve these without calculator because these are easy ones. You know, some calculations they just you can solve them without calculator. A tennis ball is released from the rest at the top of a tall building, which graph best represents the variation with time t of the acceleration a of the ball as it falls, assuming that the effect of air resistance are appreciable. What they're saying, a tennis ball is released from top at the top of a building, of a tall building, which graph best represents the variation with time. And you have the effect of air resistance as well. Hmm?
Telephone.
We have solved this one as well, similar to this. Keep this in mind. This is the key
Yeah,
word.
we just did it.
Hmm.
So the effects of air, they're like there. Appreciable
Appreciable
means.
means it will be. Air resistance is there.
So it's not B.
No, it's not B. It can't
It's
be
not A
A.
either.
Yes.
So it's C, I think.
How can we see?
B is going down like negative.
So that is correct because you know air resistance is there. Due to air resistance, they are not saying negligible air resistance. They are saying air resistance is there. Effects of
Okay.
air resistance are appreciable. If they use the terminology that negligible air resistance or they use the terminology like there is no air resistance, then you can choose the option in which the acceleration is increasing. In this, they have clearly mentioned that air resistance is appreciable. It means there is air resistance. So, due to air resistance, the acceleration will decrease. Now, the option is D. Okay. Are you clear with this?
Yeah.
I think you are sometimes you just want to.
No.
Okay.
No, I'm just. That's it.
Yeah. You're just thinking about this.
Yeah.
Okay. Good. A motorcycle stunt rider moving horizontally take off from a point of 1.25 meter. I wish I could do this. Above the ground, landing 10 meter away as shown. What was the speed to take off?
Speed. They're
Hmm.
asking for the initial speed.
I don't know what they are asking. You must know this because you have done so many past papers, right?
I've only done with you on. It's
By
not the same
yourself.
as
Okay.
it is.
They are saying, you know, in this you need to know firstly you need to know what they have given you. They are saying that takes off from a point 1.25 meters. What is this? Is this T? Is this S? What is this?
This is this is S.
Yes, this is S. Landing 10 meter away. This is what is this?
This is horizontal. S.
Hmm. Or
Horizontal
what
velocity.
was the speed at takes off? Basically, you will use. They are talking about the speed in which it will fall, right? It will fall the speed over here.
Yeah.
So, which formula you can use?
They've
You
already
need to
given it.
basically you need to know horizontal speed, right? You need to
Yeah.
know the horizontal speed.
And you can equate them by what? Like the time? But they
Yes,
didn't indicate
exactly.
the time.
So you need to find time first. Simple. Firstly, you will find time. And which equation by which equation we can find the time?
S equals ut plus at squared. 1 over 2 at squared.
Ut plus at square. There is no initial velocity, so you can use half at square, right?
Yeah.
Ut will be 0. Okay, now which s you will use over here?
1.25.
Why?
1.24. Because first you find the vertical, then you can equate it to the.
Yes, exactly. This is 1.25 half 9.8 into
T square.
t square. Now solve it. And tell me what you get for time. 1.25 into 2 divided by 9.8. Mm-hmm.
Then you square root it, you
Hmm.
get 0.50 or 0.51.
That is 0.5 seconds. Okay. Now you have time and now you have this horizontal distance. So you can easily find horizontal speed, right?
Yeah.
That will be V equals S over T. That is S is 10 and that is 0.5. So your answer can be like if you just solve it, it will be
It's
somewhere
20.
there. Yeah, and that will be 1 and 2 and 2 will be multiplied 20 meters per second. You know how to solve these fractions without
Why
calculator?
do I need to?
Huh?
Like if I have calculator, I don't use
Okay.
multi.
Use your
You
brain.
use.
You know my teachers always say, use your brain.
I don't like math.
Okay, what you are asking?
You do all your calculation without
Calculator.
calculator.
Most of the calculation. Because when I gave the entrance exam, for MBBS when I was in after my grade 12, we don't they don't allow us calculator for physics questions. So
Is
we
it
have
now? Is
many.
it allowed now?
No, it is not allowed for MD-CAT. It is not allowed. You need to know to do the calculations by your own.
What about
So mhm.
what about the like the sine, cos, all that stuff?
We
You use it
memorize
without
those
calculator?
values. We memorize for 0 degree, for 30 degree, for 60 degree, for 45 degree, and for 90 degree. Most of the time they test you 0 degree, 30 degree, 45 degree, and 60 degree and 90 degree. That's why we memorize for sine theta, cos theta, and tan theta. We memorize those values. And that was hard. That's why I'm saying you that your A level is easy. As compared to that, your physics is easy because you are
Yeah,
using calculator and you can use these things, but we were not allowed.
they should allow.
I don't
It's
know why they.
physics.
Yeah, I don't know what they test in the. I I
Yeah.
I didn't get this. Okay, question number 19. You have in the absence of air resistance, a stone is thrown from P and follows a parabolic path in which the highest point reached is T. The stone reaches a point Q just before landing. The vertical component of acceleration of the stone is what? What is that? They are saying a parabolic path. What is a parabolic path? Just like the parabolic path? It's like the projectile motion. It's similar to
Yeah.
that. So now they have mentioned in the absence of air resistance. Now there is no air resistance. A stone is thrown from P. This was the initial point and follows a parabolic path in which the highest point is this. This is the highest point, the T, and reaches Q just before landing. The vertical component of acceleration of the stone is what will be the vertical component?
It will be um it will be the greatest at Q.
Vertical component of the acceleration of the stone. Think about it again.
It will be 0 at T, right?
Firstly, you must know what is vertical component. What you get from the vertical component.
From the
Like you have
vertical
horizontal
component.
component and vertical component. We have done this. That vertical
But you said vertical component,
component
like it
remains.
at first it decreases.
Wasn't we?
As from that was
Hmm.
the horizontal component, you said it stays the same. But for the vertical component, like it will decrease like from P to T and then it
Yeah,
will go
yes.
back to, so
Okay,
at T it
so
will be 0.
vertical component of the stone at T will be 0. What about the B option?
What?
D option,
D?
last option.
Q the same as Q? No, it's not the same.
So I can't hear you.
It will. That's not right
Why?
because at t it will be 0.
Sorry, that is for a projectile motion. That is for a projectile motion. We have a parabolic path. I was also confused when you said that. I told you that in the projectile motion, and in that I told you that the vertical component and the horizontal component we check that. Over here, that is this parabolic path is also similar to that, but over here we are talking about that there is absence of air resistance, and this is a parabolic path. So in the parabolic path, you must know that the vertical acceleration will be constant at all point. Okay, in parabolic path, your vertical acceleration will be constant at all the points. So that is why I was saying this option that the same at Q as at T, and it will be same
It
at P as well. It will be same. The vertical component will be same in the parabolic path.
for a parabolic path it
Hmm.
remains constant.
Yes,
But I didn't learn this.
you we will learn this in the dynamics as well, and we will do this. But
Okay.
for because this
I,
is
th-
in the
I
question,
thought
you must remember this. Hmm?
okay. I thought it would be the same as. I thought it was like
Yeah.
a projectile motion, so that's what I was saying.
Some things are similar, just like the force. When you know the in the when we what we say in the projectile motion, the force acting on the projectile motion is equal to the gravity, right? The gravitational force, and that is vertically downward. And when we talk about that there is constant force, so your G value is 9.8. You remember that I told you that in that case when we were discussing projectile motion, I told you that uh, according to there will be constant force. Force will be constant, and that force will correspond to the G value, and that G is 9.81 meter per second square. If you remember that,
Yeah.
and the vertical velocity is changing. Okay, the vertical velocity is changing. You see, its vertical velocity is
And
changing.
what
Hmm?
about the horizontal?
The horizontal component in the over here. Can you repeat your question?
What about the horizontal component
Of the
in
parabolic
parabolic
path.
path? Yeah.
This is, this is same. This is similar to the projectile motion. I'm not saying that these are the two different things, but the only difference over here in this question, we are discussing it in the absence of air resistance. That is why we have chosen this option. Otherwise, I have told you that the just like in the projectile motion, we have discussed that the horizontal component remains constant. Parabolic and projectile motion are same. Just I am telling you over here that in these options you cannot say it will be zero at t because we consider that the vertical acceleration will be constant at all the points. At all the points. I am not saying throughout. I am not saying throughout. I am saying at this point, and at this point. Are you getting my point? What I am saying?
So just like the vertical, it
Yes,
will change.
at t and q, not throughout the motion.
Okay.
But when we talk about the horizontal component, that remain hmm,
The same.
constant throughout the motion.
Okay.
throughout the entire flight. Clear?
Yeah.
Okay. This will confuse you. Most of the time, the practical questions are like this, but by practice, you will get them. Inshallah. Okay. Now, when a car driver sees a hazard ahead, she applies the brakes as soon as she can and bring the car to rest. The graph shows the speed v of the car varies with time t after the hazard is seen, which graph represent the variation with time t of the distance traveled by the car after the hazard has been seen. Okay, whenever you have questions like this, like there is a huge statement, first you read the question. And if you get the question by just reading it, then solve it. Otherwise, then you can read the statement as well. Sometimes they just give you stories. I don't know why they give so much long stories in the questions. They can directly ask you from here, isn't it?
Wait, I don't get the question. Let me read it.
They're saying when a car driver sees a hazard ahead, she applies the brake
Yeah.
as soon as she can and bring the car to rest. The person like me will not apply the brakes. The graph shows how the speed of the car varies with time t. Now, this was the initial velocity. Then she applied brakes. So, what will happen? The velocity will decrease. Now, they're
Yeah.
saying which graph represents the variation with time. Which
So
graph will be? Hmm?
the displacement, they're asking the displacement of the graph.
No, they have given you the distance time graph. This is
Okay, the
distance time graph.
distance time graph.
Yes.
So the distance covered at first it will be.
Hmm.
I think it's. I think it's B.
Firstly, you must know. Huh? How is it
B
B?
maybe. B. B.